code is written by humans. Yes, with LLMs, yeah, there is some automation, but still, a lot of code is kind of written by humans. It has to be tested by humans and looked at the security by humans. And when I say humans, I call them as problem-solving professionals. And mostly in my research, I have looked at different expertise. And when I say different expertise, I mean is expert professionals, developers who work in industry, who have a lot of software engineering experience, novice programmers, students who write code or who are learning computer science classes, or end user programmers. When I talk about end user programmers, these are the people who write code for their living or for their hobby. So for example, an accountant writing a spreadsheet is kind of end user programmer, or a physicist writing simulations in MATLAB is an end user programmer. And then I am also interested in inclusivity. I have looked at gender, but the two ends of gender, like men and women. So again, this is a gray area. People, what they identify themselves as, that's what their gender is. But mostly in our studies, when we looked at it, was either men or like they self-identify themselves as men or women. And also race. Recently, one of my students is working on race in the US, like black and white, and trying to study how they kind of collaborate. So these are some of the people or humans I have been interested in past 15 years. And when we think of these humans interact with computers, and usually through IDEs or some kind of interface in which they kind of interact. And according to Norman, there is a gulf of evaluation or a gulf of execution. So gulf of evaluation is when the computer gives the output how humans understand. And execution is basically how people work on the computer. So my interest is how we can narrow this gap down between people who write code and IDEs or interfaces which exist in computers. So towards that, today's talk I will talk about some examples from different expertise and gender, and also effect of collaboration. So let's start with the first half of the talk. So if you look at debugging, different expertise have effect on what kind of error messages are generated. According to a PI study in 2021, they found was error message readability and usability is still a problem. And we think it's 2021, it's so long, coding has been there for so long, but still error messages, which is a simple thing, is so hard for people to understand. So for professional programmers at Google, there was a study in 2014 where they found that confusingly worded messages took 12 minutes on average time of a developer. And it took 30% of, it affected 30% their build in order to build the code. And usually for professional developers, they are used to them. So for them, it is frustrating. It affects their productivity. But for novice programmers, there has been so many studies that error messages are really kind of very hard for undergrads or basically students to understand. And there's a lot of literature on that. And one of the studies where they looked at eye tracking, 25% of the time, these students were just focusing on error messages, which is a lot of time for a student to kind of focus on other than thinking about how to write code. And poor error messages, it may affect whether they stay in computer science or not. If you think of if it is really maybe this is okay. That's hearing sound. Okay. So and these are two groups of people I talked about: professional developers and students. Then there is another category which we talked about, end user programmers. So during my PhD, I was looking at Yahoo Pipes. It doesn't exist anymore. It was closed in 2014, around the time when I was kind of putting my dissertation together. So Yahoo Pipe was pretty popular around that time. It was a mashup environment. What it allowed to do was allow anybody to write code by a visual language. As you can see, there are different nodes which you can put together. So it was mostly for web development. If you have 2 or 3 different kind of websites, you can put them together and do some kind of filters or operations and then see the output. So for example, if you want to buy a bike, and you have Craigslist, and you have Amazon. So you can take those two websites and maybe filter on the price range and some kind of features, and then you can see the output from both websites together. So it allows that kind of operations, which is kind of pretty cool for end user programmers instead of writing code themselves. But the error messages were very hard. As you can see, the error messages response OK 200 error invalid XML document. If you are from HCA field, it's very clear that you shouldn't have that kind of message to a user because the user won't understand what does that mean. Or there were no error messages, nothing at all. So you couldn't even tell whether there is an error or what is going on with my code. So what we found was there are very few environments which even support debugging in end user programmers environment. And 76, according to one study, 76.3% of the time was just spent on debugging alone instead of writing code. And in our own study, like of 50,000 pipes which we collected, 64.1% contains some kind of bug in them. And in my own studies, like when we were conducting the human subjects, what we found was a lot of time they were spending was either figuring out within the IDE where the error exists or problem exists, or they were going to the web and then trying to figure out. And web, you can think of it as wild, where there are so many possibilities of solution. It's really hard to find what is the exact solution for it. So in order to support that, what we started to do was classification of faults. Like what kind of faults does exist in Yahoo pipes? So in Yahoo pipes, like I said, it had like two modules. So what we looked at was within a module, what kind of errors can exist and what the interaction of two modules. And you can think of it as like in a class, what errors can exist, and between two classes when they're interacting, what kind of errors can exist. So thinking from that aspect, intramodular and intermodular kind of errors which existed. And then how can we automate that anomaly detection? Because if we are going to provide debugging support for end user programmer, it will be hard for them to figure out where the error is. We need to support automatic generation. So that's where kind of other, for professional developers and end users is different because the IDE should support automatic kind of detection as well as support system. So to find automatically any kind of errors, we looked at static analysis techniques, which in software engineering, like data flow, because most of the code was how the data flow from the input to the output, or dynamic analysis, how the results were returned and what kind of results were returned, trying to figure out anomalies from there. And also checking some rules using assertions. So we use these automatic techniques in order to kind of figure out where the bugs were so that we can show to the user. And this was the backend architecture. So there was a proxy server. So Yahoo Pipes was Yahoo's. So it was kind of not open source. So in order to kind of deal with, or the code could only be run on Yahoo server. So what I did was I wrote a proxy wrapper around the proxy server where it would intersect all the code and put it in local database, find the anomalies there, and run the code on Yahoo server. In that way, we could kind of figure out if there were any anomalies or whatever I wanted to do with the code which was coming from Yahoo. So this is how the Yahoo Pipe environment looked like, and this is what we added. So there was a panel on the right-hand side which would give, automatically detect the errors, and which would give the list of errors. As you can see, number of errors, and it will also give in which module there were errors. And the way we created was there was a to-fix list, which we called as, and then the module which was erroneous, that would become orange so that the attention of the user goes there. And they were kind of linked. If you hover over your cursor here, that will expand there. Or if you expand there, this module will get highlighted so that you know where the error is existing. And the way the error messages were designed was, first it was giving just overall in few words what the error is, then more details on that, and then also some kind of hint or explanation what they can do around it in order to fix it. And in our studies, we found that participants were able to fix 1.55 times more than when there was no error messages or this kind of support wasn't available. So the takeaway from this work is that we should design effective error messages for everybody, for students or professional developers also, rather than just end user programmers. And again, and provide some kind of constructive communication so that users can know what they are supposed to do. And in order to, especially for end user domains, usually you try to understand that specific domain of interest which you are interested in, then you model it, model like basically how the environment works and how are the parallels between the software engineering field and this field, and then apply some SE techniques and create better interaction mechanism so that end users can use it. Another is like different expertise and history of work. Like when you work on some code, you leave your history or behind, right? So in end user development, they don't design upfront. The requirements keep changing. So they don't follow a software engineering process the way professional developers do. So their design and coding is kind of interleaving. And they also debug programs into existence, which means they debug as well as write code. And so because of that, a lot of time they create they have these different ideas which are kind of lost somewhere. So in order to kind of support that, we were kind of motivated from a study by Jones and Scafidi, where they observed that end users need a versioning control system. At that time for programming environment, because they're not going to use GitHub or Git kind of environment or configuration management kind of environments, because it's hard, you have to push requests and all. So what we want to do is automate the system instead of like having them do anything. So the way we did was like if they hit on the save button, it was more like a commit, and it kind of logs whatever they have done. So as you can see here, it is version 1. Whatever the modules were, they would be kind of listed, and then when they would run, it was more like a baseline, so that you know that how many versions of till what module the code was working, and maybe what was added later on that maybe can add some kind of error into it. And then there was also orange whenever there was no result or some kind of error, then it would show. And then tested was mostly manual. So basically they could click on it and then it would show that, okay, till here I know my code is working, and after that you start working again. So kind of helping end user programmers to think about like what are their versions, and we also show them their parent version. So hovering over would show what was the parent version of that particular version. Like here version 5, its parent version was v3. So that means it was copied from there, maybe there was a backtracking in between. But if we think of these kind of, it leaves a lot of partial states, a lot of states which also needs to be managed. Similar kind of work or partial states which are harder to extract is done for end user programmers. Yester code was another tool which was created, which was mostly for LabVIEW. So in LabVIEW also there are nodes, and so there was a timeline slider. You would move and you can see the history, kind of a time lapse. And then there was another one, time lapse, which was basically again like time frame, but you can see the JavaScript code for web development. Another for professional developers as well as novice programmers was Azurite, which was for Java. Again, it showed over time, and you could also diff between two versions to see what were the differences between those two versions also. So it allowed kind of look at the code and over time, how the history looked like. So these are some of the tools which exist out there. But again, this creates a lot of variance. A lot of variance means a lot of similar kind of code because these are versions of each other. So foraging over space or history of a project. So what we found, like we did a survey where we found that 88% of end user programmers said that they create a lot of program variants. That means they create similar kind of programs. And 82% said they don't use any kind of tools in order to track their variants, which means they don't use any configuration management tools. And instead of using any tools, they rely on their own memory, which is more cognitive load for them. So we created a kind of app inventor helper. This was for app inventor, which is a Android mobile development environment. But the idea was to visualize how the lifespan of a project looked like. As you can see, these edges showed how much code, similar code was there. So the bigger the edges are, that means a lot of code was copied. If thinner, that means less code was copied. And these showed error, like number of errors there were. And different colors, like each had like meaning. So that means these were from different authors. Or for each app also, you could see it's like more details, like that who was its author, how much errors it has, how much similarity of code it has with previous version, like here it shows 37%, little bit of description, date when it was created, updated, and downloaded. So the stats on that particular project. So this was kind of visualization which was created to help developers understanding how their project evolved over time. Or like, who has copied it, like overall picture of the project. So again, it is not scalable, but at least for end user programmers, if there is not much history, then they can at least see it. So takeaway, one solution is not enough. Like we saw for professional developer, there are different kind of support system for history which was created. Different languages may need different kind of support if it is visual versus text-based, and need better tool support for their end user programming activities. So it also depends upon what kind of language it is, what kind of tools there are, that may also affect, like, what kind of tool, how the support system should look like. Another is like code comprehension and how gender affects the information processing. So usually, like to support gender, a lot of things are being done around the world. A lot of second education, like they understand in computer science there is less percentage of women, and people are trying to help to reduce this gender gap. But if we see the IDEs, a lot of IDEs, like if you know Eclipse, in that, like if you hover over a function, you can see the details of the function. This is called selective information processing style, which most of the IDEs do allow. And this is what usually statistically men like to use. They like to understand what the code is doing, and then the selective information processing style is theirs, like style of understanding the information. And then there is comprehensive, where it is like all the functions, whatever you have, you can pin it, like whatever the details of the function is, you can pin it. And this is actually women problem-solving style. Statistically, women like to understand whole code before they start solving it, and which is not supported by most of the IDEs. And this is just a simple change. Instead of hovering over, you just allow pinning, which is just a simple IDE change that can maybe affect how women come to computer science or like computer science or not. So in one of our study where we allowed comprehensive information problem solving style into Gidget. Gidget is a programming environment for kids to learn like teaching concepts. It contributed to increase in number of women who were interested in doing programming. So just like small these changes may affect like how we have inclusivity in our area, just changing the idea. So the takeaway is improve the interfaces for different problem-solving styles, because we are humans, we have different styles. If we can support different styles in our environment, that may help everybody instead of only few people. And it may help in inclusivity of the tools. These are some of the problem-solving styles, which according to research, they have found differences between statistically between men and women. So again, like it doesn't mean it is like blue and pink kind of thing. It's more that some characteristics, maybe being a woman, I may have, which comes into men category. But the idea is if you support all kind of problem solving, then you are helping everybody else. So learning style, like it is process-oriented for process-oriented learners, which means you like to go through a process or follow a process, then understand And learn by tinkering, which means like playing around the things and then learning about it. Information processing style, we talked about it. Comprehensive, which means you want all the information before you start solving. While selective is whatever the first promising thing is, you start solving that and then you go over to the next step. Motivation wants technology to accomplish something, while technology is source of fun. Attitude towards risk, don't like to take risks, while technically or statistically men like to take risks. And self-efficacy or confidence is lower than their peer group for women than men. So these are like, some of the things which you just keep in mind when you're designing your technology to make sure that there are no differences. This was mostly work by Dr. Margaret Burnett, and she created a gender map tool to kind of look at these differences in the products, software products, so that technology doesn't have those kind of differences at all. So information seeking or gender and how variation foraging kind of intersect. So usually developers spend it's known that 35 to 50% of their time navigating the code itself. And 50% of that yields to less information, yield less information than developer did expected. And 40% needed more effort than it was predicted. So in GitHub, like a lot of time, in order to find a code, you have a search. You can search for keywords and then you get results and then you can find a project. Similarly for Stack Overflow, you can search for your questions which you are looking for. But search is not a great solution. It is rarely used. It's time consuming for developers to process the results because they have to go through all the list manually. Most navigations are to recently visited codes because that get high hits, which means it will be more and often lead to irrelevant code. So we used information foraging theory. So information foraging theory was kind of started in 1985 for information, around when the computers were starting by Peter Piroli. It was his PhD dissertation, where what he found was that information processing is similar to the way it's optimal foraging theory in the wild, where a predator looking for a prey is similar to, in our example, a developer looking for a bug in the code, looks for the patches in the wild world, which is similar to IDE, by looking at cues, like some kind of information out there. And this whole theory has been used a lot in order to optimal foraging theory, like this for the wild animals or biological sciences, but for programming and IDE development or understanding the information processing, this theory has been used a lot. And what it does is it models cost and benefit, cost and value. So you won't go to a place where it is costly, but it should be valuable. Maybe you are okay to spend more time if thing is more valuable. So you kind of balance around cost and value. The idea is you try to maximize the value and lower the cost. So it is modeled, there's a mathematical model for it, but also it is also helpful qualitatively analyzing what are the cues in the environment they are looking at, what are the strategies they use in order to process the information or navigate around the information. So in our studies, what we found was for Stack Overflow, this is over time, the kind of cues they used. So I will just talk like a bigger picture that women participants spent 30% more time and utilized 21.24% less cues on GitHub. So this is over GitHub, like how the participants were working. These are M is for men and F is for females. And men participants utilized 55% more time and 19.7% more cues on Stack. And this is how it looks like. And if you see, like men participants were having hard time on Stack Overflow and women on GitHub, if we think from that theory of information processing or like basically gender differences, GitHub has a root structure, which needs a lot of tinkering, which may be what we conjecture is more like a men problem-solving style, women like process-oriented. or comprehensive. Maybe it doesn't support that. That's why they didn't. While in case of Stack Overflow, it is not that much hierarchical. It's just question and answer. So you don't need to really navigate. All the information is there. So the code comprehension is much easier. And it doesn't, so men need selective information processing and tinkering, which is not supported in this environment. So just the different kind of problem solving, like, few things if modified, maybe it may help both genders to kind of perform equally or forage equally. So the takeaways, behavioral theories may help understanding human behavior and designing interfaces and algorithms. So in the past, we have used foraging in similar variants, created a variation foraging theory, which means if the programs were very similar, how people forage through them, and how we can model it. So the modeling was done, and we created models, PFIS, V and PFIS H for hierarchical and variance, which may help in finding the variance. Because when the code is similar, then it's harder to find. So overall, we talked about gender effects. The takeaway is that we know that problem-solving styles are different. So look for different problem-solving styles when you're looking at the environments. There's methodology called gender mag when I was talking Dr. Burnett's work. So there's all this HCA methodology which you can use for looking at your product or the software you have created, whether it allows both or like all kind of genders to solve problems. How to find gender differences, conduct user studies or conduct studies on the literature, look at literature. A lot of time you also get answers from psychology because people have already found it. You don't need to kind of reinvent the wheel, but you try to see, does the similar behavior exist for professional programmers? Find significant differences, and once you find differences, then you try to create affordances or your interfaces around that. For end-user programmers, map professional environments. So usually, whatever software engineering, like you may map like for configuration management. Actually, we thought about configuration management and thought about push requests. Like what will be equivalent of that? Saving, running the code, So we try to map those simple things and model the behavior. So a lot of time you can find solution either from software engineering or even AI. A lot of things can be automated and try to create intuitive interfaces. And in order to create intuitive interfaces, first you have to understand human behavior, their struggles, where they struggle, look at previous HCM methodologies, if there are any lessons learned from there, and use extensive user testing in order to improve your interface for programmers. So nowadays, actually, a lot of work mine is on collaboration. Collaboration with AI, I will start with that. So this is work which I have been doing for 4 or 5 years now. Not recently that much, just because I don't have a PhD student who is working on it currently. But this was before LLMs came. So if you have questions, like it's similar to LLMs, so let me know. I will love to answer those. But the idea was there are no conversational agents for programmers. So if we think of conversational agents, they are all around us. They are task-oriented conversational agents like Siri, where basically you give it a task, it solves it for you, and give you the answer. Google Assistant, Alexa, all these are task-oriented conversational agents. Then there are social chatbots. What they try to do is they try to increase the interaction with the user because they want the person to feel involved with that. So these are social bots, which tries to increase the time of interaction, while the task-oriented should have shorter duration, because that means they have done a good job in finishing the task. So Cleverbot, Zulus, Mitsuku, these are some of the social bots which are out there. Even Snapchat has social bot, which can also give like positive quotes or whatever, like if you ask it. And 2/3 of the websites which exist out there, they have some kind of AI support. So if we think of AI is almost everywhere, or these kind of conversational agents are everywhere, but we don't have any for programming tasks. So that was the motivation behind this work. At that time, there was nothing, and now also there are no conversational agent as such, but there are automated ways of getting the code. So no conversational agents exist for programming tasks, and in order to start thinking about how a futuristic conversational agent should look like, is that like if we want it for a programmer, what programming like methodology we can adopt that may help in kind of making it a better conversational agent. So in order to, we got motivated by pair programming. So pair programming is when two people write code together. One is the navigator and another is the driver. So driver is the one who writes the code, navigator is the one who looks at the code, and after a while they exchange the roles, and they keep on doing that until the task is completed. And pair programming as well as remote pair programming, both of them are known that it improves the code quality. This is like a biggest, like last 20 decades of research has proved that in industry as well as in academia, it helps increasing the quality of research, code. It increases the confidence because two people are looking at the code, so you know that the code maybe is better because it is being also code reviewed at the same time. It also increases productivity because there are ideas coming from two heads. Two heads is better than one. It also narrows knowledge gap because each individual learns from each other. And it also narrows gender gap. So there have been studies where they found that women enjoy doing pair programming. So in that way, it also like helps in gender gap and reducing the gender gap. But it's not all like, great. There may be some scenarios where pair programming doesn't work. For example, Tiana is a sophomore student who wants to complete her programming activity or assignment, and but because of pandemic, she has to go back home, and all his classmates are also at home. So she wants to finish the assignment, but either they don't have similar expertise, or they take credit of her work, or the schedule is conflicting, or they may criticize her for things which she may not enjoy. So the advantages of pair programming kind of goes away. So the idea is, what if all these disadvantages, maybe they won't exist if we have a conversational agent in between, which can interact with Tiana and help her in completing the assignment. So according to us, what we think the advantages will be having a conversational agent it will be unbiased towards its race and gender, if it is properly trained, again, because the biases will exist if AI is not properly trained. Also, there was a study in Nature in 2017 where they find as soon as you see somebody within 20 milliseconds, you make assumptions about that person, whether you like them or not. We like, we are born like racist or whatever you want to say, like judgmental human beings. And even when you hear somebody's voice on the phone, within 2000 milliseconds, you make assumptions about them. So the idea is, if we have like an agent which is properly trained, maybe it won't make assumptions about that. It can be created to motivate and encourage if it gives those kind of quotes to the programmer. It can also be created to have healthy problem-solving strategies. There are different problem-solving strategies which can also be supported by the IDEs or environment itself. We have worked on Idea Garden before, so which kind of tries to integrate within the environment those problem-solving, so that participants or people who use it can do it without knowing it or learn those techniques. It also avoids power balance, especially for pair programming, where one person may end up in doing all the work, the other may not do. It can be non-judgmental, can give non-judgmental feedback as well as actively listen to it. So these were some of the advantages we thought will be if we have a conversational agent. But there are challenges. So one domain of software development, there's nothing which exists out there. There are no benchmarks. It must support implementation, testing, refactoring, those kind of phases for a software developer. User basis programmers, which is different than if you have to book a restaurant or if you have to book a hotel. There are different skills, they need different kind of experience also may affect, and interfaces and interaction needs to be different because again, for pair programming, it needs both technical and soft skills. So the domain is different, so these are some of the challenges which exist. So in order to start thinking like how should we kind of create, in HCI there is always that you first create the interface, then you implement it. So we started thinking about the design of conversational agent, and with our literature review, and I will talk about how we went over. So we started with conducting human-human studies, where we observed how two programmers work together and understood like what they're doing. And then based on that, we created a pilot wizard of full study. And we also looked at transferability, what are the things which can be transferred. So in case of wizard of full study, those who doesn't know, it is basically a participant is working with the computer and they think the responses are coming from computer or AI, but it's actually a researcher who is sending the responses. So it's kind of a wizard behind the scene which is generating the responses. But the way it generates the responses is how a machine should have generated the responses. So in order to create those responses or how the machine should respond, we had a whole script which researcher followed, which was based on the literature from HCI, foraging, AI, psychology, education, management, gender studies, intelligent tutoring system. So based on that, we thought what is kind of available at this time and how the interface should look like. So based on that, we had wizard, and we conducted the studies, and then we looked at human-human study wizard, how the behavior was different, and based on that, we conducted another study, which was a bigger population, and the interface was designed better, and the script was better, again, looking at the literature. And this is like in the end, we got the design. The way we designed the agent was, one was interface and interaction. So interface was like it should have a 3D avatar, there should be choices of gender, there should be a voice, text, it should be more human-like, and interaction, like because it's pair programming, it should be driving, it should adapt to the other user, give some kind of feedback. Also the typing speed, it shouldn't be like fast, just pasting the code, it should be more like human-like, so that the other person understands how the code was written, kind of. And then this was something different. Technical skills and social skills, this should be extra than what other conversational agents have. So in our past study, we created a visual resume, which was looking at technical and social skills. So the idea is the professional, when hiring is done by managers, they look at not just technical skill, they also look at social skills. So both skills are very important for a developer. So in order to create that persona of a developer, we looked at technical skills and soft skills that the agent should also score these. So basically, code contribution, test case generation, problem solving. So these are some of the things which are already available. Then soft skill like read each other, motivate each other, show uncertainty, show a social presence to the person. So this is like the design. This is a Tokai paper which is like 40 pages long. If you're interested, you're more than welcome to look at it and feel free to ask me questions if you have. So once we have this agent design, the next step was, will this really work? Is it as effective? So we wanted to see the feasibility of such an agent. So in order to see that, whether we can bring the benefits of kind of replacing a human being with an agent, we conducted a study of human-human and human agent. And then as you can see, the p-values are not significant, which was good news. That means, and these are the major characteristics for pair programming, that productivity, high productivity, code quality, self-efficacy. These are important characteristics like, or the benefits pair programming provides. So when we looked at this matrix, the p-value was not significant, which was good news. That means this conversational agent can be beneficial. And some of the qualitative things we found was partly because the agent had access to a lot of resources and could give the answers. You can also think from LLM perspective, and it can give you a lot of answers, so at least it has access to all the knowledge of GitHub which exists. So it helped them, especially getting unstuck if they were stuck somewhere, getting some kind of template code or direction so that they can make a progress towards it. Human partners trusted agent more, which was not very good thing. And this is also known in other areas that humans really trust computers a lot. And sometimes it is kind of dangerous. Similarly, they all the code which was given by an agent, they didn't try to modify or refine it because they thought it must be correct because it's a kind of AI which is doing. And they actually, this was positive that they were not scared of interrupting the agent or ignoring the agent because they didn't need to do any social cost towards that, which with another human they do. You don't want to make the other person feel bad about them. So where it would have helped them, they could ignore the agent. They can be vulnerable to show that they don't know because you can't do that to your friends or your colleagues. But agent partner could not explain, which comes to explainability of AI, which needs to be kind of improved further. So we have the design, we found it is helpful. The next step was, since it's a conversational agent, can the machine learning algorithms understand the conversations of a programmer? Because again, that is not looked at. So we looked at feasibility of machine learning algorithms. So in case of natural language understanding, when two people talk, there are a lot of intrinsic factors which are there, so we can communicate easily. There may be body language, there may be some words you can communicate, but you can understand what the person is saying, but AI can't do that. It needs, or machine needs, to understand the intent behind every conversation. It needs to be labeled, and then only machine learning algorithm can classify the conversations. So in conversational agent literature, they look at dialogue acts. So all these, conversational agents, about in Alexa or Siri, a lot of time for booking, restaurants or hotels. What they have done is they have dialogue acts. They label with the dialogue acts, which is based on speech telephonic conversations, which were labeled, and then they got more data through workshops and all to train their systems like Alexa and all, which is improved over time. But these dialogue acts are kind of used a lot in conversational agent, and these are some list of dialogue acts. So what we did was we used the dialogue acts and we labeled the human utterances. So we had 3,436. When I say utterance, it means a sentence a human was saying. So each sentence was kind of labeled with something out of these dialogue acts. And then we used SVM, simple algorithm, because we just wanted to see if machine learning algorithm feasibility basically. And what we found was the accuracy was 57.91% if you don't do class weights or if you do balanced class weights. When I say balanced, what it means is some conversations, for example, sentences maybe are 500, but then some conversation acknowledgement is only 4 or 5. So what in AI they try to do is when it is balanced class weight, every conversation is extended to be balanced. So that the data is kind of balanced instead of different for each conversation. So the accuracy went a little bit down, but again, it was still 55%. We also looked at the feature importance, and what we found was that only 11.67% had the conversations were domain specific. So this was about conversations were about tic-tac-toe games. So tic-tac-toe game related variables came only kind of almost 12%, which means that we can kind of utilize other English-based machine learning algorithms. So still there are challenges. NLP challenges. One is collecting the data, because we need to create benchmark for programmer conversations. So one way is lab studies, the way we did, either visitor-food studies or human-human studies, or maybe we can also do online videos. So there's a lot of online videos which exist on pair programming, but if we collect that, videos and label that and transcribe instead of conducting these expensive studies. Another is generating labels. So the labels we used previously were dialogue acts, which is for hotel booking or like those kind of conversations, not for programmers. So that means we need to create new labels for developers or for programming. So these are some of the labels we created. So these labels were created from AI perspective, that a human is conversing with AI, what kind of labels it should have. Like, what is it trying to do? Like, is it a question? Is it a recommendation? Is it a task goal? Like, is it attending some specific location? And we created these labels, and then we labeled it our data, so which was both human agent, which was 8,324. And then we looked at, is it possible to use large language models? So this study is a little bit before when GPT-3 just came in. So at that time we had GPT-2, BERT, and ExcelNet, and we compared the conversations we had, label data, whether it was able to classify. And if you can see here, it's almost 80%. And the accuracy of all of them was almost similar. And maybe the accuracy may have increased now even further with the models being better. And BERT was actually a little bit better. So we analyzed our most of data using BERT at that time. And then we also looked at gender effects. So all those conversations, what we tried to do was we used BERT model. We trained it just on all men data and tried to predict, like, for men, like testing, like training and testing. So the accuracy was 88.77%. Then we had a BERT model, we trained it on men data, tried to predict women data, and the accuracy was 69. Similarly, we used a BERT model, trained it just on women data. So one thing I forgot to mention, that our studies were gender, like equal gender. So we had this whole data which was equally distributed. So women data and predict on women, the accuracy was less than men actually. And then when we trained the model on women and tried to predict men, it was 67.16. So which is, we don't know why it is, because again, it's machine learning algorithms, but this kind of gives you an idea that it's okay to use if we have the conversations around, just like, because again, computer science is more men-heavy field. So if we have those conversations, it is okay to design it for women, like, conversation prediction also, which is a good news. That means the online videos, maybe you can use them, even if the gender equality is not there. So we also looked at feasibility of using online videos. So for when we had human studies, the accuracy of BERT model was 68%. When we had, human and agent, then the accuracy was 68. Human decreased because again, it's harder to make prediction. Human has a lot of different kind of conversation, which is harder to maybe label. And then there is a concept of transfer learning. In AI, a lot of time, all these conversation agents do that. So basically, they train the model on human data, then they fine-tune it with human agent data. So that's what we did, transfer learning, and the accuracy increased. So usually the idea is, because if you have these two, that means your data sample has increased and the accuracy of model is going to increase. That's why usually with transfer learning, the accuracy of the model increases. Then we looked at the YouTube, we labeled the YouTube videos, and the accuracy was pretty lower than the human studies. And remember, these studies, like all the human studies, they were all around tic-tac-toe game, but now we have different languages, different domains that may have affected accuracy. And then we use transfer learning. We trained it on YouTube video, then on human lab studies, then on human agent. Basically, we are fine-tuning the model for specific, and the accuracy increased. So, which kind of gave like, okay, we can maybe use YouTube videos, especially for different domains and languages. So that is the work we have done till for conversational agents. So this is how a conversational architect look like, agent architect. So natural language understanding, a human is talking and hearing. So natural language understanding, this part was the what I talked about. But then there is whole this part, dialogue state, act, tracking, and dialogue policy, which means whatever the human is saying, whatever is on IDE, based on that, it gives some kind of answer, or it processes. And in backend, usually either initially we thought was we can have database of programs and based on that it can, but since LLMs have come, there is a possibility that we can use LLM in the backend to generate the code and then use it. We don't know, still needs to work on that, but that's what the idea is. So this is the ongoing project which is going on. In future, like automated test case generation can be done at statement and test level so that when a person is trying to talk with the agent or conversational agent, they can test their code and talk about every statement so that they can generate the test cases. Same for code generation. And also, like I talked about explainability, that whatever the answers, how it came to those answers, it should explain about that so that human can understand because it's a conversation agent. Any questions till now? Okay, so the other work is with another human. So I do have one or two other studies, but I will just talk about one on gender, gender effect in collaboration. So we conducted a lab study and then interviews. It was pair programming. So we had same gender and mixed gender pairs. So blue and pink is basically mixed gender pair, blue is men pair, pink is woman pair. So it's like, that's why I was saying it is more like binary because it is easier to study that way. And what we found was in case of leadership, authoritative, when it was a mixed gender pair, it didn't, irrespective of gender, one person kind of took over the whole pair programming. According to them, the whole pair programming work happened. But when it was same gender, they were more democratic and listening to each other. Primary communicator role, women felt when they know something, they wanted to be a navigator, but men, when they knew how to write code, they wanted to be driver. Remote technology preference, women preferred in person. For men, it was indifferent or they preferred online. Either they didn't care or online was good. Communication, women used a lot of nonverbal communication. When we looked at over time, you can see these are female participants, and there's more kind of smile, laughing, confusion, like more facial expressions than the other pairs, like the men. Then we conducted, based on these studies, we wanted to understand if it really exists. So basically for management literature psychology, we also looked at other differences which existed, and we conducted a survey where we had mixed, so we asked if somebody was man, we asked for the answers you are giving, it was perceived gender of the other person, but by thinking about whom you're answering these questions. So these are the perceived gender. You can think of the second side. So for leadership, we felt women said men dominated. When they were working, women felt other women were giving them more constructive feedback. Women felt they could ask other women for help, and the women felt men interrupted them. Women and men felt it was harder to communicate online with another woman, which can come to these nonverbal cues that maybe those were missing because there was computer in between them. Nonverbal cues, men said women use more nonverbal cues. Gender-based assumptions, women felt there were more gender-based assumptions. And trust, men said the other men were more rude towards them, and there was also hurtful feedback. So these are in the survey, statistically, with the differences we found, what people said. But what does that tell us? Because I personally feel nobody tries to hurt anybody. It's more there are differences. And a lot of time it is more in your head, oh, this person is making assumptions about me. And what we can do through technology that may help. So maybe one way, something gender map kind of technique, if we can create when it is remote work, at same methodology for effective collaboration, or a facilitated conversational agent, which we are working on. to see how effective collaboration can be done when two people are different, automatically predicting their behavior and then kind of making it more empathetic towards each other. This is last which is going on. So I don't have much results to discuss, but it is about teams, collective foraging intelligence. So usually for software development, people work in teams, and there is a possibility the same code, like for example, a browser is being developed by 5-6 different teams around the world, right? Safari, IE, like the different. So there's whole this, in order to create a project, there's this collective intelligence of team which is involved. It's just not one person. And if we think of, there may be different teams and the intelligence is kind of distributed across, like around the world or globe. And it is distributed across continents and time zones, and which may be, and then also the developer, they are also dealing with a lot of heterogeneous sources. They're working in IDE, they're working on like looking at Stack Overflow, GitHub, Internet. They're looking at collecting information from different sources, patching it together, and then working, which is more time and cognitive effort. And it is more of information seeking problem, which means you look at information, and we talked about information foraging theory that may help us in understanding how they forage for information, how they look for information, what is valuable to them, what is costly for them. And based on that, like I said before, like in previously, we've worked on foraging and created a model. So for debugging, we created a debugging model. For variance, we again created a mathematical model, and similarly for end-user programmers in online repository, how they look for information, we created a reuse model. So these models may help in kind of, if we use them to automate the process, but most of the work, especially for foraging, like how people forage for information, has been done like for individual programmer or individual human being, not as a group, but team, how they forage. And most of the things, even like ant society or mammoth society, people work waggle dance of bees or ants, they leave pheromones. Similar to that, we think the teams also leave their pheromones kind of with logs, and maybe we can utilize them to collect the collective intelligence of these people. So that's what the idea is, to create a model, IFT model, which is for teams, and create a recommendation system and make a more generic model which can be used beyond developers. Yeah, and I would like to thank my students who have worked with me and funding agency who pay for all these tricks and my students. And that's pretty much all. So I want to make like software engineering accessible to everybody. Thank you for me. I'm happy to take questions.
Thank you very much. Questions?
I have a question. Those studies that you're running, the interviews and follow-up without being remote, do you get them from, for instance, from your university, or do you get teams from different?
So we actually conducted a lot of wizard ones. We conducted remote because it was during COVID time. So we conducted them remotely. And now after that, most of our studies are kind of remote because what we found was that it was easier to get more participants from other universities. So in that way, there are more participants, and especially for inclusivity, like, if we want equal numbers of participants, sometimes it is much easier to do remote than in person in the lab. So we have been doing more remote actually.
And I was wondering about the homogeneity of participants. For instance, if they had all been educated in a certain setting, do you have same similar habits or you see instruction?
Yes, and there is a possibility because most of these studies are in US. Even if most of the studies which were conducted remotely, we try to keep it in US because of technical issues and like IRB or whatever, like paying them So most of the studies we tried to keep within US. They were also like I had an Air Force grant which did need a US citizen or at least people in US to participate. So I will say these generalized to US population, not maybe to Brazil or Asia or like other places around the world.
It's very challenging for us to conduct some test studies because we're not allowed to be participants.
Mm-hmm.
You know. So
Yes.
I mean, even if we had them, we usually don't. But but also I was wondering, how longitudinal have you managed to get? So you talk about, okay, these people are working and then they feel moved or whatever. They change styles. So I was wondering if you expose like a pair, men and women, do they change? Do they adapt to each other's style
With over time?
Yeah.
We haven't done that, but that's interesting. Like, if they are always working together, maybe they do start adapting to one person. Maybe not together, maybe just to one person, who knows. No, we haven't done any longitudinal studies with the same people.
Because especially because the last slides that you had about the agent as a facilitator, I was wondering whether the agent could be sort of, when I look at facilitator, I see someone intermediate, like between, whereas it could be like coaching. Like maybe you could, help people adapt their style to be better at, interacting with the other person or having somehow, if they adapt to a partner, so maybe they, the agent would help them adapt, not only convey the content or whatever technical issues.
So the one study, I just remember that in human studies, we also find mimicking, which was like if the other person was smiling, they started also smiling, they were trying to kind of behave, to make the other person, even in other race studies, actually, that's what people they were like, you have to be careful what you say to the other person because they are from a different race. So they were trying to empathize, mostly people do try to I think most extent, sometimes they may not realize when they're doing it. So that's why I feel if we can automatically detect, okay, the person over time, we have AI techniques, for facial expressions and all. And if the confidence is going down, they look like they were happy in the beginning and they're neutral and they seem sad, that means something is going wrong. And maybe something needs to be done about it. That's what the idea is. We haven't implemented yet. My students still working on it, but we will see how the studies also show. But I'm sure that kind of question will definitely be there because I think longitudinal study can tell, does the facilitator agent really helps? Because over time, are people adapting to each other? Are they being more empathetic towards each other? And it's okay to have different styles, but understanding it's a different style, it has nothing to do with you, but it's their style of working and letting them do in their style.
Yeah, but also, for instance, when you think about the problem solvers, I'm sorry, monopolized here. And you talk about Margaret's previous study of problem solving styles, how these styles evolve over time, depending on how you're exposed to different teams and so on. Because I was wondering, because some people who are more selective, maybe they would benefit from having a more holistic version, so on and so forth. So,
because you always learn. Yeah.
So, I mean, if I process oriented versus tinkering, maybe someone who's process oriented should,
little bit tinker.
Would be aided by some strategies, some tinkering strategies, and try to do.
So that's interesting. Your perspective. Yeah, giving them that educational nudge to it. That maybe you can use this technique, but letting them decide.
Exactly, or just nudge. When you think, for instance, today, cognitive overload and whatnot, and filter bubbles, instead of, okay, you have the style, and then this is how you should, this is how you can be more productive within your style. It's like, okay, take a look at this,
Yeah, different style, different, yeah, because,
experiment a little bit.
Again, pair programming, that's what it is trying to help with knowledge transfer.
Yeah.
It's a different style of this person, learn from it. Instead of forcefully doing, it's intrinsically, kind of you just observe the person and you learn, oh, this thing works. Maybe I can also learn this technique. So it's more like that.
Experience, not as in a position, but as if you're exposed to diverse ways of thinking, it will increase your toolbox.
Yeah, and you will be more successful in solving the problem. Yeah, thank you. Yeah.
I like the idea of having different interfaces that benefit different genders. And I was thinking about configuration management. What's your feeling about what we have of user interface for Git, for GitHub, and if it can be adapted to be more tailored to different gender? Do you think it's kind of global, or it benefits men or women?
I think like in Git, isn't it like there are studies that 95% are men on GitHub, or 98%. So which is the answer that what is going on, isn't it? Maybe it is more tailored towards, but at the same time, like if you think of the information processing, is mostly hierarchical. Like all the information around the world, that's how the information is organized. It's hierarchically organized. So I don't know, like I said, with studies we did find that women were spending more time. So maybe the way the interface should be, it should give some kind of like expert or like some small overall what this folder is about, instead of just the name. Because statistically, if men like to tinker, they will play around and figure it out. But if they don't, if women are like risk averse, they don't want to kind of go somewhere, they feel like a rabbit hole and will go deep and figuring out will be hard. Maybe it will be good to have this explanation in the beginning. Yeah, so that they quickly read it and have an idea. But I think that will benefit both genders. It's not just one, because instead of them tinkering around, maybe they will also know whether they should go or they should not go, instead of wasting their time tinkering. So that is just my thought. We don't know until we conduct studies but according to me, that makes sense. But again, we don't know until we kind of conduct studies or talk with people, how developers would really like, or how students would really like.
I'd be interested to conduct some cross-cultural studies to see how people differ
In foraging also.
I have a question. Do you think companies are concerned about gender effect on
Oh no, definitely not. Nobody cares. I don't think industry. I mean, they say because they save taxes. Maybe I shouldn't say because I'm saying it on YouTube. But I don't think industries care, isn't it? Everything is about money for industry. Making benefit, like profit. So they don't care about inclusivity and all. They do talk about things, I think, but I don't think they very, very care. But at the same time, yeah, until it sells. If it is affecting their sales, yes, they will care. Right? But otherwise, I think ideally, it won't. Margaret's that gender may also kind of work, because she got an email from one of the companies, their sales, and they had lots of women kind of their clients, but they were not coming to their website, so they were wanting to understand what is going wrong. So that's where, and when they their method worked and it increased the sales, then they were interested in it. So they need to see some kind of if it helps their businesses and all, then they will care for sure. It's all about money. I don't think it's anything with gender. I think it's all where profit is. I mean, that's what I think. Okay.
Okay, we have a few questions here.
Yeah, sure.
I will read. Was this study able to find results of productivity which be different decisions that each gender has?
Productivity in there.
Productivity for different genders.
We didn't look at productivity for genders. Yeah, we didn't look at like, if productivity was as such different in genders because our data wasn't that huge. We had only 3 pairs of mixed gender, 3. So statistically, we cannot find differences.
Out of curiosity, did the person who asked this, or was it a man or woman? Just checking.
It was awesome. Nice.
Well, don't you think that when it comes to productivity, companies might be interested?
Yeah, if it helps with productivity. Yeah, but our study was like small, the lab study, the other was survey, so we didn't know like how did they produce the code. So yeah, so that's why we couldn't like for race we had like at Kai the paper got like slammed. Why did you talk? It was only one research question where we talked about productivity, and people didn't like it because the sample is smaller.
What do you think was like your biggest challenge in this research? Because I'm also how to conduct a survey about communities diversity in software engineering. The biggest challenge you're facing right now is to get responses from the survey themselves.
Well, then,
Like,
so my student is conducting interviews with the challenges you have in finding participants for inclusivity, because we were having, I was talking with Juliana before. So she is actually conducting, maybe I can give you a name to her. We are trying to figure out what we can do as a software engineers to have like, when there is problem with inclusivity, how can we increase the participants? Because it's really hard. And maybe like you said, like with Brazil, since they're not even paid, then it's like even more harder to get people. So I think in our solutions, it was incentives that people like to get some kind of incentive if they're getting something, money and all, then they will participate. But again, like, it will be interesting actually, like when you don't have money, then what techniques you use to get the participants.
You need social capital. You need social capital.
didn't work. Didn't work. Lagging, no.
Maybe you're not a good bagger. I'm just kidding.
Well, you answered.
Yeah. Actually, for me, mostly the participants I got was the people like when I was a student, I would ask my friends, can you please participate? Like that's how I always got like, participants. Even now, like my previous students, I was like, can you please participate? I would send you. Because sometimes we don't even care about money. We do pay money, but for them, their time is more important than money, especially when they're professional workers. Students can come. With students, we don't have that much trouble, but for professional programmers, it's really hard to get them.
Okay, one last question. Would you say the programs of IDEs and today came more from PUC or from the algorithms they can provide?
Algorithms like the backend maybe of IDE.
They help
I mean, like I want. I don't understand the question, but what I understood is, I think the person is trying to ask is if the UI are the problem or if it is the technology behind or backend is the problem. Maybe is that?
I think, what do you think about the programs that we have today with the IDEs for gender diversity and so on?
Okay. So, like I said, I think most of IDEs don't even support these problem-solving techniques. So, like, if they support, maybe it can increase, who knows. But like error messages, I mean, simple error messages, that will throw away anybody. If you can't solve a problem, you will start feeling like a failure, isn't it? So, I mean, just having a simple error messages, which is easy to just change the wording. In HCI, it's just it's a principle. You have to give a message in a way a human understands, and nobody in software engineering is doing that, which is kind of sad. but that may affect even, it's not just about gender, like any other students, maybe they are really smart, but they
Yeah.
think that they're not good at programming because these error messages or like, simple things are not there for them to support until like, you really kind of keep playing around it.
And what about the ethical points of view? Because someone asked here, how to deal with ethical points within the world of AIs involving IDEs, such as exposing sensitive goals to external companies.
Yeah, so basically like LLMs and all, because they are giving away code of other humans. So, I mean, that's still kind of isn't a huge research area where people are still studying ethics. So, I mean, ideally, like, we are in academia, so I personally feel it's okay if you are contributing towards greater good. But again, everybody has different viewpoint. Like if it is your good, you don't want everybody to kind of take it until like you allow it. Again, like similar maybe I will be more cautious towards my pictures or videos. I don't want somebody to just use it. It's the same thing some people may feel about the code, but some people like who are in open source, they're okay with it. So yeah, so it's kind of a thin line. I think it should be according to what people want. If they're okay to letting their code be there, it's okay. But if they don't, then they should have the right to keep it to themselves or not allowed to be trained or LLMs. I think LLMs are like nowadays ChatGPT is trying to do like you can like kind of buy the private one and then it would be just trained for you, that kind of thing. But I'm sure like whenever if I'm shopping for something, I will get those ads on Facebook. And then like I did it on my laptop, but I'm getting it on also my mobile. So they of course they take your private data and also which is unethical. But which is more, I think, politics kind of thing, isn't it? Like the rules and regulations, how they should be set up by government so that companies don't kind of exploit. Because at this time, data is a huge thing.
So I wonder whether when they train LLMs with other people's code that was online, if they read the license files to see whether they could. And not only that, I mean it's one thing. So I can put my code online and say, okay, this is licensed. If you use it, you just need to give credit or not. But then LLMs cannot give credit because they don't really know what
because they're on machines.
and and they make profit, so at some point they have like these tiny bits that are public, but then to really leverage the power of LLMs, you have to pay for them. Whereas they didn't pay for the code that they find. So it has an ethical.
Yeah, I think it can only be changed if the government can steps in. But our politicians are mostly old, they don't even understand what is going on.
You cannot regulate them something that doesn't exist. We have a law now, it didn't exist before, there was no regulation.
So people are also still understanding what is going on.
Thank you very much for this.
Thank you for having me.
Have a nice weekend, everyone.
It was